Quantum mechanics emerged in the early 20th century as scientists began to probe the microscopic realm and found that classical mechanics failed to explain the observed phenomena. The development of quantum mechanics can be broken down into several key events and contributions from various physicists. Blackbody radiation, 1900. The first quantum concept came from Max Planck, who introduced the idea of quantization to explain blackbody radiation. He proposed that energy is quantized and comes in discrete units or quanta, which was a revolutionary idea at the time. Photoelectric effect, 1905. Albert Einstein expanded on Planck's work by explaining the photoelectric effect, wherein light striking a material can eject electrons from it. He proposed that light consists of discrete packets of energy called photons. Bohr model, 1913. Niels Bohr introduced a model of the atom where electrons occupy quantized orbits around the nucleus. While the Bohr model was successful in explaining the spectral lines of hydrogen, it failed for other elements. De Broglie hypothesis, 1924. Louis de Broglie postulated that matter, like light, exhibits wave-particle duality. He suggested that particles have wave-like properties, which was later confirmed experimentally. Matrix mechanics, 1925. Werner Heisenberg formulated a version of quantum mechanics known as matrix mechanics. He introduced the concept of quantum operators and the uncertainty principle. Wave mechanics, 1926. Erwin Schrödinger developed wave mechanics, another formulation of quantum mechanics, where he introduced the Schrödinger equation that describes how the quantum state of a system changes over time. Statistical interpretation, 1926. Max Born provided a statistical interpretation of Schrödinger's wave function, interpreting it as a probability amplitude. Pauli exclusion principle, 1925. Wolfgang Pauli formulated the exclusion principle, which states that no two fermions can occupy the same quantum state simultaneously. Dirac's quantum field theory, 1927. Paul Dirac extended quantum mechanics to incorporate special relativity, laying the groundwork for quantum field theory. Copenhagen Interpretation, 1920s. Niels Bohr and Werner Heisenberg formulated the Copenhagen Interpretation, which posits that a quantum system remains in a superposition of states until observed. These developments, among others, laid the foundation for modern quantum mechanics. Over time, quantum mechanics has been further refined and has become one of the fundamental theories in physics, providing a comprehensive framework for understanding the behavior of matter and energy on the smallest scales.